Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the integration with natural logarithms. This is part 11. If you haven't checked out the other parts, make sure to do so and remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Diving into what we'll be looking at today. Recall, integration is the reverse of differentiation. Then, if y is equal to natural log of f of x, when we differentiate this, we would get our dy dx as f prime of x over f of x. Therefore, if we reverse that, we would have the integral of f prime of x over f of x dx being equal to the natural log of the absolute value or the modulus function of f of x plus the c. Let's label this as equation 1 because we are going to refer to it over and over again. But before we continue, let's talk a little bit about the modulus function or the absolute function. Now, you would recall that natural log of 0 or any other value that is below 0 is undefined. So for that reason, we turn to use the modulus function, or known as the absolute value, with the two vertical lines. Let's move on. So this would imply that if we are integrating 1 over x dx, our answer would be the natural log of absolute value of x plus c. Let's label this one equation 2 or formula 2. And for the last one, we have the integration of 1 over ax plus b dx. Now with this, we are going to have 1 over a times the integration of a over ax plus b. Why? Because the a's will cancel out. And as we have that, according to what we had in formula 1, then that becomes integration of 1 over ax plus b dx is going to be 1 over a times the natural log of absolute value ax plus b plus c. As easy as that. And recall, our a, b are elements of real numbers. Let's take a dive at example 1. Integrate the integral of 7 over x dx. The solution here. Before we deep dive, let's take a look at the common mistake. This is where one would do like this. The integral of 7 over x dx is equal to the integral of 7 times x to the power minus 1 dx. Nothing wrong with expressing that according to the laws of indices, but this approach is a little bit tricky. Why? Because then some people would turn to add 1, divide by the answer, in this case, which is impossible to divide with the 0. Then they get the answer they get there, which is extremely wrong. Note, when n is equals to minus 1 for x to the n, we would use the formula 2, which is integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. And with that in mind, we are going to use that approach. So implying that the integral of 7 over x dx, remember from our previous videos when we spoke about the integration when multiplied with the constant, we can actually take out the constant 7 in this case out of the integration function so that we have 7 times the integral of 1 over x dx. And with that, from formula 2, we have ln x. Then the final answer becomes 7 times ln x plus c. And don't forget the absolute values of x. But in cases where we have positive values of x, then there wouldn't be any need for us to put the modulus function, absolute value function, because the values are already positive. We do so to avoid negative values. Let's move on to example 2. So we have this question over here, integrate 1 over 3x plus 1 dx. So the solution, as you would recall from formula 3, what we had was 1 over ax plus b dx is equals to 1 over a ln absolute value of ax plus b plus c. So that is when we integrate any function of that particular form. So we take note of our a. Our a in this case is a 3. So if we decide to go the way of finding the derivative of the denominator, we would have 1 over 3 times integral of 3 over 3x plus 1. Why? Because the 1 over 3 and the 3 will cancel out, so that we have the original f of x, which we were meant to integrate, to be precise. Then, with that, we would get our final answer as 1 over 3 times natural log of absolute value of 3x plus 1 plus c. Recall, our a is a 3, so we didn't have to use the second step that we used there. We could just plug in this a into formula 3. We get our answer as easy as that. Now, let's take a look at example 3. Now, example 3 is an interesting one. Why? Because firstly, we have to find the quotient and the remainder when 6x squared plus 5x is divided by 2x minus 5. So recall once again from our previous videos in the division of polynomials, where we looked at various ways of dividing polynomials. We looked at area model approach, we looked at the long division and the synthetic division. So in this case, we are going to make use of the synthetic division part 2 video. Make sure to check it out. It carries a lot of insight. So with that, we are saying that if we divide 6x squared plus 5x by 2x minus 5, we can set the divisor to 0 and substitute for the x to be lambda, so that we solve for lambda, we get 5 over 2. With that, we spread out the coefficients of x starting from the leading term, x squared, and we have 5 and 0 for the last one, which is the constant, which we do not have in this case. So we drop the 6, we multiply that 6 by the lambda, we get 15. 15 plus 5, we get 20. So 20 times lambda, we get 50. 50 plus 0, we get 50, implying that 50 is our remainder and the quotient in this case. Since we have a divisor that has a coefficient which is not equal to 1, in this case the coefficient is a 2, so we divide by that 2. So the 6x is divided by 2. The same goes for the 20 divided by 2, so that we get the quotient as 3x plus 10. Then we are saying 6x squared plus 5x divided by 2x minus 5 is equals to 3x plus 10 plus 50 divided by 2x minus 5. Make sure to check out the polynomials division video once again, so that you recall some of these things and learn new approaches. Great, we are done with question A. Let's move on to question B. So I'll repeat the question once again so that we see what was meant to be done. So moving on from A, we know that if we integrate from 0 to 1, which we divided the 6x squared plus 5x divided by 2x minus 5, we are going to get what we have on the right hand side, which is that. Then we integrate term by term, because that's how we can integrate in integration. However, we have a fraction there, which was the remainder part. So with the remainder part, we can actually take out the 50 because we are multiplying with a constant and trying to integrate with a constant. We can just move out the constant out of the integration function. So in this case, what we would have is that. And then remember, from formula 3, we learned that we can actually integrate such functions. And in this case, our a is a 2 and our b is a minus 5, but we don't really make use of that b after all. So when we apply what we learned from formula 3, we are going to get this function over here. So we have 3 over 2x squared plus 10x plus 50 times 1 over 2 ln of the absolute value 2x minus 5 and integrating from 0 to 1. Now, before we substitute our limits, let's try to simplify what we have in the square bracket or parenthesis. So if we do so, we are going to get the same terms, first and second term, but in the third term, this time around, we are saying that 50 divided by 2 gives us 25, and every other thing remains the same. At this stage, we can now substitute with the upper limit and the lower limit. Doing so, we recall that we start with the upper limit, then we subtract the lower limit so that we have these two expressions that we have here on the right-hand side. Then with this, simplifying further, we would have 23 over 2 plus 25 times the natural log of absolute value of negative 3 minus natural log of the absolute value of negative 5. Now take a look at the issue we spoke about earlier on. If we try to evaluate the natural log for negative values, we would get an error or something that is undefined. So to avoid that, we introduce the modulus function or what is known as the absolute value function. So in this case, if we activate the functions, what would happen is we would have the negative 3 turning to a positive 3 and the negative 5 turning into a positive 5. So every other thing remains the same. And moving on, we factor out the negative from the curved parentheses or brackets so that we have 23 over 2 minus 25 times natural log of 5 minus natural log of 3. Why? On the left-hand side, the ln 5 was negative, but this time around is positive. And the ln 3 was positive, this time around is negative. Why? Because we have factored out the negative. Why are we doing so? Because we want to show that that integral results into 23 over 2 minus 25 natural log of 5 over 3. Now, according to the laws of logarithms, and especially natural logarithms, when we have natural log of 5 minus natural log of 3, what it means is we have the natural log of 5 divided by 3. So make sure to check out our future videos where we talk about the properties of the natural log. Let's move on to our last example, which is example 4 for the day. Great. We have integrate this integral of 18x squared plus 4 divided by 3x cubed plus 2x plus 1 dx, the solution. Recall, in the denominator, we have our f of x as 3x cubed plus 2x plus 1. Now, if we differentiate that, we would have f prime of x, which is equal to 9x squared plus 2. And with that in mind, we go back to our integral. And now, with our integral, we can actually factor out the common factor above, which is the numerator. If we do so, we are going to have 2 times 9x squared plus 2. The denominator is still the same. And take a look at this. What we have multiplying with the 2 is the f prime of x. Great. Then, according to the laws of integration, we can factor out the 2. But before we do so, let's check out the formula 1 that we spoke about. So the integral of f prime of x divided by f of x dx is equal to the natural log of the absolute value of f of x plus c. So now, going back to what we have on our left-hand side of the screen, we can see that we can factor out the 2 from the numerator so that we have the numerator and the denominator. But there is a relationship between the two. The numerator is the derivative of the denominator. And with that in mind, it means that our answer comes out as 2 times the natural log of 3x cubed plus 2x plus 1 plus c. And of course, not forgetting the modulus function. If you have made it thus far, I say congratulations to you. I leave you with the following task. Integrate from 2 to 3 of 2x squared over x cubed minus 1 dx. Remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Thank you so much for watching Numbers Simplified. God loves you.